Hey folks, so today we will talk about the graphs and semantic memory and all of things. And one of the interesting topic that usually when you start with the directed graphs and the knowledge graphs and semantic knowledge, you're all bound to the triples when you try to describe the relations, and you have the usually the binary relations, like that you have the subject, object, and predicate, and we could go far with it. So entire industry working on it. But then we faced with the multiple challenges. And for example, one of the challenges when you model the triples as a RDF, that for example, you want to add the metadata and maybe some properties to the ages itself, and you have no ability to do it. And after that, people came with the RDF star model that give you the possibility to add the metadata to ages, but it's still more like the workaround. And we need to understand that the RDF and the RDF star is more the serialization formats, so it's not really representing the concept. And one of the way of find the marriage between ability to add the metadata to the properties, to model the property graph and RDF graphs, actually is the layered graph. And I had a separate article, I will leave the link in my Medium blog that will be the counterpart to this video, that I already described how actually people do it. But how actually people do it on Excel, that they just give the possibility to reference the age as a node, and that's it. So that's the main concept how we model the next layer. We just pretend that our ages actually is the nodes, and then be able to build the new relations. And actually this little trick allow us to do a lot, because then you could actually model every property in a property graph in this way. It could create a bit of noisy graphs, but it could give you the power of, for example, time traveling and all other things, and you could create the temporal layers and all other stuff. But the idea of representing the relations and ages as a node, it's quite interesting, and I borrowed this idea from the the layered graphs, and but we still bound it to the binary relation, right? And what's more interesting, that we could borrow yet another idea from 1984, so the year when I was born actually, that SOVA offer us the interesting idea of the concept graphs. And concept graphs create this biparty graph where you have the entities and you have the relations as nodes, and in biparty graph you have the ages that have no labels or have quite fixed structured relations that just connect the nodes with the relations. And it's quite cool, because right now you have the full power of the nodes. You don't need to have the layers or simulate the layers, and you have the full scale node as a relation. Maybe it will make your the graph database, especially if you have the property graph database, a bit crazy, because it's really change the shape of your queries and make the queries more complex. But it gives you a lot of superpower. So the concept graph, you have then relation, as a node. And then you see we have the layered graphs that represent the age as a node in some point. Then we have the concept graphs that represent the entire relation as a node. And what I take from it that we could go further and we could model a graph of graphs. So we could have the subgraphs. So we could have the complex relations as a subgraphs that allow us to break through the binary relations. So, for example, you could have the multi-party relation that represent the relation of 3 or 4 or 5 or any amount of entities. You could still have the binary relations between these 4 or 5 entities, but sometimes you simply have the relation that have this triple of entities that do not have maybe the binary representation to each other. Or it allows you to heavily compact the graph. Because, for example, if I say that Volodya and Lilia like traveling to Switzerland, yeah, for sure we could make the relation that Volodya like traveling, Lilia like traveling, then create some binary relation between Lilia and Volodya. So you see that we start emulating these complex relations and we, as a result, create more relations. And the subgraphs, it's a cool concept. But the subgraphs force us to use the graph of graphs and some nested structures, and it could be complex to the representation. And then we could get the benefit of the layered graph again. So maybe we could make the nodes that represent the complex relation of multi-graphs and put it on the same graph as a node. So then in your node you will have, in your graph you will have the coexisting graphs that just project the subgraphs to the same space. And it's actually quite viable concept that you don't have the real nesting and you simulate this nesting with some kind of special edges and special relations. And together with the concept graphs, it's really create quite interesting structure that I'm trying to discover right now. And if you want to know more about what we are doing in the space of the memory for the artificial intelligence, why the concept graphs and subgraphs matter for modeling the complex human-like memories, just let me know. I will be happy to talk about it, and see you next time. Choose.